Thanks for the opportunity to make a presentation here in front of this ASHRAE Congress. I would like to talk about intelligent control valves in today's HVAC systems. And here you see the overview of the presentation. With intelligent control valves, it is possible in the future and already now to have a pressure and temperature independent valve, not only a pressure independent valve, but as well a temperature independent valve with delta T management to avoid the low delta T syndrome. And as well, I will talk about data management and IoT, what is possible today with control valves to get the data, even with cloud solution and energy monitoring. We know all about energy efficiency. Everybody is talking about energy efficiency, and we are all forced to limit the global warming. And with modern control valves, we are able now to, as well on a heat exchanger level, to control this energy efficiency. We know that buildings use about 40% of global energy and 25% of global water. Buildings offer the greatest potential for achieving significant emission reductions in all over the world. Energy consumption in buildings can be reduced from 30 to 80% with available technologies. That means it is already possible today with today's technologies to reduce energy consumption direct at the heat exchanger. Building sector is estimated to be worth 10% of GDP, of the global GDP, and employs 111 million people worldwide. Residential and commercial buildings consume 60% of world's electricity. Existing building represents significant energy saving opportunities because the performance level is far below current energy efficiency potential. So we can do a lot more with energy saving direct on heat exchanger level. And many buildings suffer from a low delta T syndrome. What is the low delta T syndrome and how we can avoid this, I would like to show now in my presentation. Low delta T syndrome, if you have a heat exchanger with a supply and a return in a heating application, we have a supply temperature and a return temperature. And what we call the low delta T syndrome, I'm sure you have already heard about this syndrome or about this name, is a mismatch between supply and return temperature. So I have too much water to have power output and an energy consumption at the heat exchanger. Here you see the characteristic of a heat exchanger. The more flow I have, the more power I get on this heat exchanger. And the delta T curve looks like that with more flow, I have a smaller delta T, a smaller differential temperature between supply and return. Now, at a certain point, this curve here will be flat. Typical behavior of a heat exchanger is when the curve will be flat, I pump more water around in the system without gaining more power output. In this waste zone here, you have seen this curve, so this curve will be flat, the power output curve. So I have too much water pumping around the circuit, and when I pump too much water around, I I have a very small delta T, I have inefficient use of energy, higher operating costs on the pump side, and no extra power on the heat exchanger. This is what we try to avoid with modern control valves. The low delta T syndrome, we have many parts when the low delta T syndrome occurs. One of that, if water systems are not balanced very proper. So all the water system, you know, I read a story from Germany that about 80% of the water systems in buildings are not proper balanced. That means I just pump water around and around, I don't get the right energy. The energy is not correct at the right time with the correct flow rate. The heat exchanger also get dirty with time, so I have a stuck heat exchanger, I have an old heat exchanger which is not working properly anymore, and too much water and energy is delivered. As well, one point, because of the occurs when the low delta T syndrome is coming up, heat exchanger and valves are not sized properly. I've never seen a system which is too small size. They are always too big size. Therefore, I have always too much water in the system. How can I avoid this? And here, the solution is a valve which is possible to have enough data to monitor and to have a flexible hydraulic control of the water. As well, we are talking about pressure independent system. This is one step to avoid such problems on the heat exchanger. And we can have a valve which is able to manage delta T by avoiding this low delta T syndrome. A valve which is intelligent, which can handle data management to have delta T management function inside. Here is how this valve should look like. We have now the same picture with the heat exchanger, supply and return. So this valve is able here to measure the flow rate. The valve is able to measure with two temperature sensors the supply temperature and the return temperature. Therefore, it is able to calculate power output, because power, you know, is a function of differential temperature and flow, and therefore calculate energy consumption. With this valve, we are able to monitor the system. We are able to control the right amount of energy to the heat exchanger, and we are able to give transparency to the customer so he knows what is going on in the system. We are even able to do different controls of a hydronic system. We have different modes, or we have different possibilities for a control, for a hydronic control of the valve. One of that is, you know, all the pressure dependent valve. With a pressure dependent valve, I have a control signal 0 to 10 volt, which controls direct my valve opening. But therefore, the valve opening just then controls the flow rate, and the flow rate is responsible for the power output. The power output is influenced by the differential pressure, by the coil characteristic, and by the temperature. So this is a pressure dependent valve. The next step is a pressure independent valve. We also know, which is available now on the market, the pressure independent valve controls with the control signal direct the flow rate. But I would like to control the power. At the end, the result must be controlling the power I give to the room with my control valve. Because the pressure independent valve is still influenced by the coil characteristic and by the temperature. With the power control, with the modern control valve, with power control, I am able to influence with my input signal 0 to 10 volt direct the power without any influences of characteristic or without any influences of temperature. So I have with this valve, I have a pressure independent valve with power control, and I am temperature independent. The valve determines the power output at the heat exchanger in real time, and the power output at the heat exchanger is no longer influenced by water temperature and characteristic of the heat exchanger. This is one feature of modern control valves we are able to do now to avoid problems on the heat exchanger. The second part is, or the second feature is delta T management. Delta T management, we see here this characteristic. Again, water quantity means flow rate, more power output, the differential temperature comes down, and I come here at the so-called heat exchanger saturation zone. Sorry about that. Yeah. That means here at this point I have, with more water, I don't get more power output. Now with the delta T management in a modern control valve, it is possible here to limit a certain level of differential temperature. As soon as the valve is recognized that, and with an integrated logic, we can avoid this saturation zone by reducing the water quantity, reducing the flow rate, and come back into this area where we have an energy efficient operation. The delta T manager ensures that the heat exchanger is not operated with too much water, so we override signal, we reduce the flow rate, and use of energy, inefficient use of energy is avoided. Here is a picture how it looks like in real life. So these are operating points from a real installation. We see here the red points is the power output on the heat exchanger, and with this cooling application I have here, the blue points is my differential temperature, delta T. Now I see very clear and very nice here my pump runs at 100% with a flow rate of 38 cubic meters per hour and with a power output of about 80 kilowatt. Now when you look at this curve, the same power output I can get here with 18 cubic meters per hour. I have the same comfort in my room, the same comfort at the heat exchanger, the same power at my heat exchanger, but instead of running the pump with 100% and 38 cubic meters per hour, I can reduce the flow and having there 18 cubic meters per hour. So with an intelligent delta T management, we can reduce the pump to 11% instead of 100%, and all these operating points here on the right side would be avoided. I have less flow rate and I have a higher differential temperature. See here we are here with 2 Kelvin, and here we have a differential temperature of 3 Kelvin. This is an effect when we have an intelligent control valve with delta T management. So all this area here on the right side we can avoid. And I can save here energy saving on the pump side. So once the valve is installed, or this control valve, these modern control valves are installed, I have a lot of data available, and with this data I can work with. It is a nice solution to having this data, data collection, to analyze the system, to optimize the system, and to have at the end an energy efficient operation. So with this modern control valves, we give the possibility to monitor the energy, the flow and the temperature, and to be transparent on a heat exchanger level. As well, it is possible to now, with the cloud solution which are coming up in any product, as well with control valves, we can connect them with a cloud solution to have even more profit out of that, or more possibilities, like the customer support in terms of better support for the customer. We can have an optimization together with the customer via the cloud solution, and the customer gets more transparency with performance report, and as well with software updates. We already did an installation with this valve in London, in a big building in London. It was a library with a cooling system and 120 globe valves. And by installing these valves, we give the customer more and more transparency, and we help them to optimize his air handling units. At the end, we were able to save on the thermal energy side, only on the thermal energy side, 600,000 kilowatt hours, which is in total 15% each year he will save, thanks to the installation of these modern control valves, comparing to the globe valves, which is a very nice energy saving we can achieve here with this with this modern control valves. We are able with this control valve, with this intelligent valves, we are able to have no more leakage, to have a reduced pump power on the pump side, because we have a pressure independent valve, and as well with delta T management. So for example, when you have a condensing boiler on this side, where the delta T management is very important to get a higher efficiency with a correct return temperature. So this valve is working on 3 points, on 3 important points of a building. No more leakage, reduced pump power, and better delta T management. At the end, we have a better efficiency with delta T management. We have a valve which can control direct the power output at the heat exchanger. That means we are pressure and temperature independent, and we give the customer full transparency. Energy monitoring, the customer knows where the energy is flowing, and as well we have a modern cloud solution available which connects direct to the valve. you very much.
Do you have any questions? Actually, I have one question. It is rather a twin question. Should someone size the valves according the heat exchanger capacity or according the expected flow for the system?
Expected according flow to the system.
Expected flow.
Yes.
So, should I guess that it's a valve I should put to save an oversized heat exchanger?
Again, sorry.
So, should someone say that you should put a valve like this to save, to compromise with an oversized heat exchanger or oversized, over-dimensioned installation in general?
No, normally the valve is anyway too big.
Yes.
But you can see now if it's too big, you can reduce anyway the flow rate. Even if the valve is too big, you can reduce the flow rate.
I mean, if you had an ideal installation which everything is very precisely sized and dimensioned, should I still have a profit installing a valve like this, which is, I suppose, a little more expensive than
Yes,
a valve?
if you have a perfect balanced system from beginning, then you have a very good planning which is 100% perfect, and then you have a very good installation which is 100% perfect. Then everything is perfect. You will not need this valve. But this valve is especially when you have, when is the world 100% perfect in HVAC? We know this is not possible. And with the age, anyway, it changes. You have buildings, you change the rooms, you change the energy loads in a building, and with this valve, we can give you transparency. You know what is going to happen, and you can easily change your flow rate or your energy load, even if in terms of if you change them. This is the big advantage.
It's safety against eventual errors of the study. It's a original calculation.
And then you know how good your planning was.
Yes.
It's like kind of saving your over dimension.
Yes.
It works like this as
It
well.
works like that.
Because usually we
Works like
always
this. Give you transparency what is happening in your system rather than just rely on plans on paper.
many times we oversize
All the times we
Yes.
understand.
to be on the safe side, but costly.
Yeah, it's too high, and you have too high pumping costs when you overflow the system.
Thank you very much.
Thank you very much.